Hello everyone, my name is Dhanabalan. My metric card number is J20B0740. Today, I and my teammates is going to present the mini project EFT1063, which contains 4 questions. Okay, the first question is to find the probability that we make both goals. To order to find the probability, we need to multiply the A, which is the event Arif is successful on his first attempt, 0.65, and the probability that he makes the second goal given that he made the first goal is 0.90. So this is the working for question number 1A. 0.90 times 0.65, we will get 0.585 answer for question 1A. Okay, for question 1B, it asks to find the probability that he makes either first goal or the second goal. To find the probability, we need to divide the probability that he makes the second goal given that he made the first goal is 0.90, divide with the A, which is the event Arif is successful on his first attempt, 0.65. So now let's look into the solution. Okay, now this is the solution for question number 1B. 0.65 divide 0.90, we will get 0.72. Okay, now let's look at the question 1C. Are A and B independent? Well, let's look into the solution. Okay, this is the solution for question 1C. No, they are not independent because probability of B and A is equals to 0.585. The probability B times probability of A is equals to 0.65 times 0.65. We will get the answer 0.4225. On the other hand, probability of B and A is equals to 0.585, which is not same as the answer of probability B times probability of A. So probability B and A is not equal to probability B times probability of A. Okay, now let's look at the last part of question 1D. Are A and B mutually exclusive? Let's find out. Okay, no, they are not, because probability A and B is equals to 0.585. To be mutually exclusive, probability of A and B must equals to 0. As a result, A and B are not mutually exclusive. Thank you for watching that. For the following questions, my rest of my team members will present.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Abdul Karim. My number matrix is J22A0128. For question 2, we need to find how the inning between 2050 to 2020, which they contain 16.75%. Our first step is 16.75% equal to 0.782t plus 50.2, and then we bearing 50.2 into the front minus 8 with the 16.75% equal to 0.782. So the answer of the minus is 1.55 equal to 0.782t, which is still remain at the same place. Okay, and then we bearing 0.782 into the front and they divide it by 1.55 and then the equal and then it equal to t 1.982. Next, we to find which year that content with 16.75% for the hourly earning. Okay, so now 1.982, the answer of the t plus 2050 equal to t, so the answer is 2,016,982. So the equal is 2070 years, in which mean hourly earning were 16.75%. Thank you.
Hello everyone, my name is Muhammad Nur Shafiq bin Muhammad Hakim. Now we are going to discuss the question number 3, which is have 30 marks on it.
Now we are going to the question number 3. There have 4 total equation can be gained in this question. So this is a formula in this question. 4. So the first one is the first equation is based on constraint number 1, which is x plus y less than 1200, and the second y equal 1 per 2x, and the third x less than 600 plus 3y, and lastly which is final equation is x 1 equal 1.50x plus 2y. So we are going to the next question of number 3 is B. So the graph has been drawn. There have 3 equation have been intersected within each other. So the red one is equation number 1, and the blue line is the equation number 2, and then lastly the black one is equation number 3. So next question of number 3 is C, which is this question need optimal production level for porcelain crucible and platinum crucible. So the first one we call it X equal to porcelain crucibles equal to ringgits, and Y equal to platinum crucible equal to 1 ringgit 50 cents. Which is the formula we use is cos equal 1.50 x plus 2y. So this is a table about the calculation of possible feasible points and 1.50 x plus 2y. So to sum up, maximum cost is 2,000 ringgit when we use 800 units of porcelain crucible and 400 units of platinum crucibles are the optimal production level for porcelain and platinum crucible. That's all for me. Thank you.
Assalamualaikum to the lecturer and fellow friends. I'm the last presenter. We present the question 4 for my problem statement is an architect draws a plan of UMK Jelly Hall with 15 seats in the first row, 18 seats in the second row, 21 in the third row, and so on. If the hall is to have a seating capacity of 670, calculate the number of rows must be drawn by him. So for my problem is the architect wants to draw a plan for and to have the to fulfill the halls, which is the hall capacities is 670, and it's fine the 15 seats for the first row, 18 seats for the second row, and 31 for the third row. So for arithmetic problem 1, we got the 15 for the first row, 8 which is A1, A2 for arithmetic 2 is problem 2 is 18 for the second row, and third row is A3 which is 21 seats. So the one what the gap for the each arithmetic sequence, which is we got 3, which is 18, minus 2 15s. For the distance from A1 row to A2 row, for summary equation formula, we use the Sn equal to Na plus n, which is bilangan on the number, uh, times n, negative 1, close bracket, and then divided by 2 for the d equal to 15, n plus 3n, open bracket, n negative 1 close bracket, and divided by 2. For 3n, we got we got the we fulfill the formulas according to the question problems. We got the 3n to the power of 2 plus 27n, then divided by 2. So the 3n, so we calculate it at 3n to the power of 2 by divided by 2 plus 27n divided by 2 equal to 617. And then we simplify it, or we set up the problems into the 3n to the power of 2 plus 27n negative 1340 equal to 0. So we got n equals to negative 27 plus minus power root of 27 to the power of 2, negative 4.3 times negative 1340. So we divided by 6. So we got the number of rows that what must be fulfilled was into the hull was 18 rows. So that's all from me. Thank you.